Hello, welcome to Storyboard AI. Have you ever wondered about the differences between artificial intelligence, machine learning, and deep learning? These terms get thrown around a lot, but what do they really mean? Today, we're going to break it down along with a simple, real-world example. But before that, let's understand what these terms mean. Artificial intelligence is the broadest category where any application is designed to perform tasks that typically require human intelligence. This includes problem solving, learning, reasoning, and making decisions. The AI application can follow explicit rules or learn from experience. Machine learning is a subset of AI where applications learn from input data without being explicitly programmed for each task. Instead of writing precise rules, the application analyzes examples, finds patterns, and creates models to make future predictions. Deep learning is a specialized subset of machine learning based on artificial neural networks with multiple layers. It's inspired by the human brain, excels at finding complex patterns in massive data sets, and can discover important features with no human guidance. In short, think of these as nesting squares. Deep learning fits inside machine learning, which fits inside the larger category of artificial intelligence. Now, let's visit an example of a smart kitchen run completely by robots. Chef Maria uses 3 robots each powered by AI, ML, and DL to help run her kitchen. Let's say our first robot is powered by an AI application and uses a set of pre-programmed instructions. Think of these instructions as 1. Timer is set for 10 minutes. 2. According to the programming, pasta needs to be stirred in 5 minutes, and based on the rules set, lower the heat when the timer reaches 8 minutes, etc. AI robot follows these explicit instructions that were programmed into it. It doesn't learn or adapt on its own, but it still helps Chef Maria manage her cooking times and temperatures. This is like traditional AI application, following pre-programmed rules to accomplish specific tasks. Next, we have the robot powered by ML application. Unlike before, there is no need for specific step-by-step instructions. Instead, this robot is fed with data from thousands of past orders. So, looking at all those orders and based on today's weather, day of the week, and local events, the robot can predict that we may need to prepare 27% more salads and 15% fewer hot soups than usual. This means ML robot learned patterns from past data and now makes predictions. Chef Maria never had to mention that warm weather means more salad orders. It discovered that pattern by analyzing sales data alongside weather records. This is machine learning, finding patterns in data to make predictions without being explicitly programmed for each scenario. Finally, there's the super robot powered by DL application, which uses deep learning. This robot, let's say, is also connected to cameras that monitor the ingredients. When Chef Maria places various ingredients on a cutting board and the DL robot detects 3 ripe tomatoes, 1 slightly overripe avocado, 2 fresh jalapenos, and 1 bruised onion. Based on these ingredients and their condition, the robot recommends using them for guacamole within 24 hours and suggests replacing the bruised onion. Chef Maria never programmed this robot to recognize a bruised onion or an overripe avocado. It learned by studying millions of food images across many layers of its neural network. It can even recognize ingredients it's never seen in this kitchen before. This is deep learning using complex neural networks to understand and interpret information in sophisticated ways. So you see, AI applications takes input, follows specific rules that are programmed, and gives an output. Machine learning applications do not need set of instructions, but takes input in the form of data sets, predicts patterns, and gives an output. And deep learning takes in multiple forms of data sets and connects dots across various pieces, just like how our brain does, and gives an intelligent output. They all represent artificial intelligence, just at different levels of sophistication and independence. The next time you hear these terms, think of our smart kitchen helpers. Thanks for watching!